My name is Evan Chewy, and this week on DevOps Bootcamp, we're going to be talking about databases. So what exactly is a database and how do you use one, that kind of thing. So a good way to get started with databases is to imagine a program. So imagine you're organizing your kitchen and you want all of your ingredients, all of your food, and you want to be able to look up recipes for it to see what's running low, that sort of thing. This data has relations to it. So like a recipe has lots of food that goes with it. There are lots of ingredients. Every food item is in a location. So it's like in your fridge, in a cupboard, on a shelf or something like that. It's a status. Is this food item almost done? Is there like just a tiny little bit down at the bottom? Or did you just buy it? Is it full? And what kind of food is it? Is it a fruit, a vegetable, meat, a spice, that kind of thing? So how would you try to store this on a hard drive? So you could try to stick everything into a file based on its food name, but then how do you select only food items that are expiring soon? You would need to open up every single file and check each individual bit of data one by one by one. You can also store by type, which solves searching for things by a specific type. So put them in a folder, type. But then what if I only want to grab things that are located in the fridge? So querying on this for a specific set of the data is difficult, and just managing it is a pain. And so instead we have a thing called a database. So a database's goal is to make querying data, to look at this very structured kind of data, very simple. So we can say, get me all of the food items that are expiring within the next week that are located in the fridge. And then it'll just list out the item, their location, when they expire, that sort of thing. We're going to be talking mostly about SQL databases. And a SQL database is a database that is structured around relational algebra. So what this means is that there are tables, each table storing one set of things. So like you would have a table for food and a table for locations. And then each table would be broken down into columns, each individual piece of information. So you would have a column for the name, a column for the expiry date, a column for where it's stored, that kind of thing. And each individual piece of information stored in this table is stored as a row. So each row has all of the columns, and they can be null or not null. So the milk is named milk. It expires on November 15th, and it has a foreign key to the locations table. And this foreign key just holds all of the this foreign key is what tells the database. It tells the database to go look in a different table for the information. So rather than repeating the word fridge each time for the milk and for an open thing of tomato sauce or butter or those kinds of things, you just say, hey, these are all in location number 2. And then there's another table, locations, and location number 2 is just fridge. And then it might have information like how much electricity it uses or something like that. Whatever other information that you don't care about. You don't care about the information when you're talking about food. You just care about what location ID it's in. So this foreign key calls over to the other table's primary key. And a primary key is a single unique number to that table that identifies a single row. So table for food and the table for locations, they can both have primary key 1 and 1, but there aren't two things in a single table that both have primary key 1. So if you have milk as number 1 and butter as number 2, you can't repeat number 1 because there's already a number 1. So that's the kind of like storing data in a SQL database kind of thing. But where SQL really gets its power from is the relational algebra that I mentioned earlier. What relational algebra allows you to do is it allows you to select things from a table and through foreign keys using things called joins. So what a join does is it allows you to take two tables and select either the things that are all in one that match something in the other, or only the information that overlaps or something like that. So you can see on screen right now just a couple of the main kinds of joins that you can have in SQL. These are actually pretty interesting, and I encourage you to go check them out yourself, but unfortunately, we don't really have time to go into depth about these right now. So now we're going to start with a quick demonstration. I'm going to install MySQL onto a CentOS 6 server, and then I'm going to play around with it for a bit for you. CentOS virtual machine running CentOS 6, install and configure it, and just show you around a little bit. Okay, so first thing we're going to do is we're just going to install MySQL. So it's just MySQL server. Sweet. Okay, now we're going to start up MySQL because it does not automatically start itself up when you install it. So MySQL D start. Sweet, we're good to go. And now we need to set up MySQL. So what we're going to be doing right here is we're going to be changing the defaults of MySQL. We're going to be getting rid of some stuff that they leave in by default for testing, and just make sure that it's set up as safely and securely as possible. So by default, there's no root user, but we're going to set a new root password. And to get rid of anonymous users so that we can't just like let anybody log in, we're going to get rid of root login by remotely, which means that we can't, let's say, be in France, SSH, and then just log in using MySQL. We'd have to SSH in first. This just gives you one more step of secure authentication before things get haywire. Test databases, privileges, sweet. Okay, so now we can go ahead and create our first table. So we're going to be using the MySQL admin tool with the user root to create Nobel. So what this just is doing is it's creating a table called Nobel on MySQL. So right now, I'd just like to take a real quick second, a real quick aside, to talk about configuration. So MySQL comes by default with some interesting configuration options, including a database engine called MyISAM by default, which is just like this real quick thing that they have in there for whatever reason. But it's really better in general to use one called InnoDB. InnoDB is what you'll find running in production on pretty much every place that's running MySQL in production. So it's just it's much better at caching, crash recovery, and it also has foreign keys, which are a really critical part to any SQL server in use. So it's just important that every database that you use, every MySQL instance is using InnoDB compared to the default. So now we're going to create a user because by default, we're just logging in as root right now, which isn't too good because this means that anybody with that means that any command that we run could potentially do anything. It could create a new database. It could clear an old database. It could clear a database that we don't even think that we're talking about right now. So right now we're just going to set up a new database user. So log into the database and then create user me where I am. So it's on localhost. Messed that one up. Okay, so create user me at localhost identified by password. Okay, so no rows were affected because we didn't do anything with the database. We just created a user. So now I'm going to grant all privileges on Nobel to me. Okay, sweet. So now that I've granted all of the permissions to myself, we can just go ahead and exit. And now we're going to start loading some data into that Nobel database that we created. So we can just say, we're going to download a pre-prepared database file that we have. Sweet, okay, so now it's downloaded. And then load this thing in. So what we're doing here is we're saying MySQL connect to the Nobel database, and then run all the commands in nobel.sql. So if we actually take a look at nobel.sql real quick, it's actually just a large sequence of SQL commands, just over and over and over. This is how a SQL file looks. It's just a series of commands. Sweet. Okay, so now we can log into that table, find out how to type, and then show tables will just show us the list of tables that we created. So we've made Nobel. Nobel is the only table in the Nobel database. So we have databases, we have tables. And we happen to name them the same thing here, but you don't need to. So now I'm going to say describe Nobel. So describe that table. So this just says we have a year, which is an integer field. We have subject, which is varchar. That just means a string. Subject is a string that can be up to 15 characters, and winner is a string that can be up to 50 characters. So now we're going to look at some of the basic queries that you can do on data in SQL. So there's select, insert, update, and delete. So a select query is used to get data from the database. So you select columns from a table where something. So in this particular example, you're selecting the year, the subject, and the winner from the Nobel database, where the year is 1960 and the subject is medicine. So the return is going to look something like 1960, medicine, and then the person's name. So actually, we can just go ahead and run that real quick. So it looks like there were actually two winners, Sir Frank McFarlane Burnett and Peter Madawar. So now we have some practice. So I encourage you to go run these on your own, try these out. You can just download the database like I just showed you and run these commands for yourself. So who won the prize for medicine in 1952? That's going to be a lot like the one that we just did, except instead of 1960, it's just going to be 1952. And then how many people were awarded the 1903 Nobel in physics? So that's also going to look pretty similar. And how many prizes were awarded to Linus Pauling? And lastly, and this is going to be a tough one, so no shame in hitting your head against a wall for a while. How many people have won more than once? So this is going to involve having to use a little bit more of a complicated select statement where you use a join, an inner join in this case. You're going to have to say, join this table to itself, where the first thing is, the first thing's winner is equal to the second thing's winner. So go ahead, try this out for yourself, and you can come back in a bit once you've tried these out, and I'm going to go over the answers real quick. Okay, so I assume you've either at this point done these, or you just want to know what it looks like. So here are the answers. So the first one, like I was saying, it's pretty similar. You just select the winner from the table with the year and the subject. The second one, you just second question asks for how many people were awarded the prize. So in this case, we're just selecting all of the data about them, but we're just selecting the data from Nobel with the year is 1903 and the subject is physics. So we can actually go ahead and run this. And you can see there are three people that won: Henri Becquerel, Pierre Curie, and Marie Curie. So And then there's the next one, which is how many prizes were awarded to Linus Pauling. And let's try that again. And so you can see he won a Peace Prize and a Chemistry Prize. And then that last one. That last one is a tricky one, like I was saying. So we're selecting the count of things from the Nobel table, and we're selecting N0 inner join on Nobel with N0 from the first and N1 from the second. We're selecting where the winners are the same and the years aren't the same. So we can see N0 winner and N1 winner are the same, and N0 subject is not N1 subject. It looks like we might have a bit of a typo here because it should also say N0 year is not equal to N1 year. So what that does, it would just grab any items from one table, item from the other table, and compare them, make sure that they have the same winner, make sure they don't have the same year and the same subject. So now we can just run that. And so it says, hey, we have 16 things. We can actually see what they were just by, instead of selecting the count, select the actual item. And so you can see Marie Curie multiple times, the International Committee of the Red Cross won many times, Linus Pauling won, et cetera, et cetera. Okay, so now let's talk about inserts. So this is going to be adding new information into the database. So an insert statement just takes the form of insert into whatever thing you're inserting into, and then values. And then these values are just in parentheses in the same order of columns as you created the table with. So we can try insert into Nobel, values. And so this is a fairly old set of data. I think it goes only up to 2008 actually. And so we can add this new literature prize into the mix. And boom, so now if we select all of the literature prizes, you'll see down at the bottom we have Herta Müller right here. And so now it's time for some practice. So in 2009, Barack Obama won the Peace Prize, and in 2009, Eleanor Ostrom and Oliver Williamson won the prize in economics. So you should go ahead and add these to the database. Just try to think, how could you add these in one statement? So instead of doing two different inserts, how could you insert these at the same time? SQL supports this. It's actually pretty easy. So I guess you could just try it out for yourself. Okay, so now we're going to look at the answer. It's actually just you say values and then you just do multiple sets of parentheses. So we can go ahead and insert these into our database. Boom. So it says 2 rows affected. So that means it made 2 different rows. So now we're going to deal with updates. So an update is we already have some information in the database, but we don't like it, we want to change it. So this might be like if a user inputs a new password, then you're going to want to, of course, update their old password hash to match that new password, and just so on and so forth like that. So when a database has some information already, but it needs new information. So we're going to replace the Peace Prize from 1951 with Andrew Ryan, who some of you might recognize from BioShock. Totally didn't just Google that. Totally know it's on these slides. Although actually, first what we should do is we should select star from Nobel, where subject equals peace and year equals 1951. So there is already a prize for Leon Junot, and we're about to replace it with Andrew Ryan. So we can run this update statement. It says one row was affected. And then if we rerun the select statement, now you can see the winner is no longer Leon Junot, but is instead Andrew Ryan. But let's say that we made a mistake, and let's say we accidentally added a row where we didn't want it. And so we can just delete this row. So let's say that we suddenly really don't like the 1989 Peace Prize, and we wish it never existed. So we can just run delete from Nobel, give it the year, give it the subject, and boom, it says one row affected. And so now if we select from the Nobel for year 1989, we can see that there's no longer a Peace Prize listed. So that's just about it for SQL databases for now. There's some further reading that you should do, especially if you're a student here at Oregon State University. The CS 340 class is all about databases. So you're going to be going over this and a whole lot more, like things to do with database, and then a bunch of practice writing SQL statements. You can also use SQLZoo.net to practice your SQL and to learn some more. And then there's also a fairly famous piece of writing from 1970, a relational model of data for large shared data banks, which is also maybe worth reading if you got some time. It's a 10-page thing, so it's not too bad. I encourage you to check it out if you've got some time. But now we're going to be talking about, just real quick, describing tables and then how you can use these in your programs. So a table has a bunch of rows, like I was saying before. Each row has a bunch of fields, each column. And so it's just like using a spreadsheet. And to load one of these tables into your database, they're just defined with something called a schema. And so you can create table, whatever, and then give it just the list of columns. So we can actually take a look at the nobel.sql file that we downloaded earlier. And up at the top, it's actually creating that table. So create table Nobel with year as an integer, subject as that string we were talking about, and winner as that string. But there's a lot more you can do with these schemas. So for instance, on this example in the slides, we're creating ID as an automatically incrementing number that is not null. So this auto increment, this is it saying this is the primary key for this table. And then we have at the very end engine equals InnoDB. So that's just making sure that even if the database isn't set up to use InnoDB by the config, that we actually set it when creating this table. So whenever you're using an application, there's a good chance it has a database in the background. So like anytime you open an app on your phone, Android has these things called SQLite databases. iOS has its own database that each app can use, and Windows has lots of, Microsoft has its own SQL product that Windows applications can use, all of these things. So applications absolutely love databases because it's a really nice way to store your data and to then get your data back out of something easily. So rather than having to parse files, you can just say, hey, grab this data from a database and show it to me. So application data can be stored in there. So like and anything to do with the application can be stored in there. User data such as their username, password, all that kind of thing can be stored in a database. And then also lots of things for logging. So each time that you access a certain button on browser or something, it might be stored into a database for Google to look at later to say, do enough people click the settings menu? Do we need to change it to something easier to recognize? Things like that. So logging, statistics, all of these kinds of things generally stored in a database somewhere. But SQL can be annoying to write. So let's say we have a Python program that just selects the 1960 Nobel Prizes. So this is how we would do this in Python, just to talk to a database directly using real SQL. So you have to initiate a database connection, and then you execute just a string. And then this string is the actual SQL statement being executed. And what happens is it returns just a list of the things that were returned. And so while this works, it's not optimal. And there's actually a better way to do this. That means that you don't have to deal directly with the database. You don't have to follow foreign keys yourself, that kind of thing. And that's called an ORM. And an ORM is an object relational mapper. So what this does is it maps an object to a database relationship. Because objects in an object-oriented language allow you to do things like get all of the food items in a fridge. And to do that, you could just say fridge.foods, let's say, in an object-oriented language. Whereas in a database table, you would need to do select star from foods where location equals 1. And then you have to make sure that you get that 1 from somewhere, or then you can actually nest these statements. So it becomes select star from foods where location equals select ID from locations where name equals fridge. And so it just becomes these gross long things. And so there's an easier way to do this, and that's to let a computer write these relations for you. So an ORM lets you talk in Python or JavaScript or Java or any of these things, and then it will automatically talk SQL for you. And these also do these things called transactions, which you can do yourself. What a transaction is it essentially says, stop time right here. I'm going to select these things, update these things, delete these other things, and insert these fourth things, and then restart time. And so what that essentially does is it prevents all of these things from actually being written until they're all done at once. So this prevents, let's say you have a power failure after you've updated but before you've deleted, which would leave the database in this like half state of not knowing what to do. And so using a transaction, it's either all applied or none of them are applied. And so this is just a really handy way to keep your database together without things messing themselves up. So this is what life with a Python ORM looks like. So you can just select the subject of your winner from a query on Nobel, filter by whatever, and then print them all out. So it's a lot easier to read and understand, but this also does require setting up Nobel and session earlier in the code, generally in another place where you don't have to think about it. So this is the SQL Alchemy ORM. We don't really have enough time to talk about ORMs today, but overall, ORMs are just a really handy way to make your life easier and not have to think about SQL when using your SQLite database, when using your SQL database. So I think that's just about all we have time to cover today. So I hope you had a lot of fun, or at least learned a lot. And I will see you next week at DevOps.